All right, so this is just a quick review about what the terms are. We touched on it in the last lesson, but we're really looking at it and we want to make sure that you can plug everything in really well. This term right here is the concentration of A after some period of time. So after T time has passed. This is the initial amount you started with. This right here, that's that same rate constant. It's unique to each reaction. And then this one right here, this is the time that has passed. So if you know this and this and this, you can rearrange and solve for T. Or if you know this and this and this, you can rearrange and solve for A. You get what I'm saying here? And there's one more term that is tied into this that you're going to see another video on. But you can also get from K in the first order to T1/2, which is a really useful term. So this is also the same K. Just make sure you're aware that that's the same K as this K. So if I had this and not this, I can solve for K and then plug K in. So these are the same exact K. Real quick example. So we have these terms right here. We have this equation. Then all we would do is we would just say ln of 1.1 over 9.9 equals, of negative K, which is 3.1 times 10 to the minus 1 seconds to the minus 1 times T. So that means we just need to divide both of these by that term. And sometimes I like doing this with just the letters first. So if you had wanted to divide both sides by that negative K, that would have been a great idea. So ultimately I have this is equal to T. And then I can just say that my natural log of 1.1 divided by 9.9 divided by negative 3.1. Notice I'm using the E key. That's why I'm not putting in parentheses. If you are not using the E key, you have to put it in parentheses. Just use the E key. You'll be a happier person if you do. And so my time is 7.08. And notice this is seconds to the minus 1. So I'm dividing by a divided by seconds. So that's going to make this be a positive seconds right there. One more thing, because you can plug stuff in, right? If you need to solve for something inside the natural log, just like all the other times, you're going to do e to both sides. Whoops. So e to both sides. And then what that does is that cancels that out. So that you just have the a of t over a0 equals e to the negative kt. Just don't drop that negative, and make sure you are very careful that those are consistently able to cancel each other out. So one would be like a seconds to the minus 1, and one would be like a seconds. Do you see? Or like a year to the minus 1 times a year. That's where you have to be careful with those ones.